podcast. I will be talking about battery safety, circularity, and design. Um, my name is Marc Boolish. I'm Executive Director of PRBA, the Rechargeable Battery Association, based in Washington, D.C. We are a U.S.-based trade association for a number of different products, which I'll get into. Um, we do, to some extent, also cover Canada and do get involved in international work as well, and I'll go through that as I'm going through here. I've been with PRBA now for about 2 years, and prior to my time at PRBA, I worked for Energizer Batteries, and for for more than 25 years. About half of my time at Energizer was specifically spent on research and development for lithium, mostly for lithium type batteries, lithium metal and lithium ion. And the latter part of my career there was more so in government affairs, regulatory affairs, safety, et cetera, transportation. So I cover I'm an engineer by degree, and now I work for an association that is based out of a law firm. So without further ado, I will get into that if I can get the slides to advance. There we go. Um, I'll start very briefly with an introduction to who is PRBA and who is Wiley, and I'll explain what those two mean in a second. Um, as a design engineer, where I spent a good portion of my career designing batteries and to some extent even designing devices that take batteries, I'll talk about what you are being asked to do from a actual standpoint, but also from a realistic standpoint. And just some of the challenges that you'll be seeing. So especially with limitations and barriers. And I will list a number of those, but essentially this presentation could be 3 days long if we covered everything. I'm going to focus on laws and regulations. To a lesser extent on chemical use. I know many of you are already familiar with that, and I think we can cover that at a high level. I'm going to focus most of my time on collection and recycling and safety and how that impacts design going forward. And then I'll conclude with just a quick wrap-up slide on, where do I think things are going here in the future going forward. So who is PRBA? PRBA, as I mentioned, is a US-based trade association. This is a snapshot of a lot of our members, but what we do is we represent obviously battery manufacturers, but we also represent a lot of different users of the batteries and those involved in the supply chain of batteries, all the way from mining through distribution, transportation, retail storage, even recycling at the end of life. So we have a fairly diverse group of members within our trade group, but they all have one thing in common, and that is they either make or use or process batteries in some way, shape, or form, or move them around. With what I'm doing today, as I mentioned, we are a US-based association. I will focus mostly on on North America, but there will be times when I step out a little bit and we'll talk about things from a global perspective. There are trade associations. Some of them are actually presenting as I speak now on other topics that are what I call sister organizations around the world that cover a lot of the same topics that we do, but they focus on their respective areas of the world. Within PRBA, we cover really anything that's common to the industry. So it can mean a number of different topics, but where we tend to focus on as far as activities is regulatory, legislative, and policy issues. And specifically where we probably occupy most of our time is around safety, battery recycling, transportation of dangerous goods, and to some extent fire codes and because batteries are becoming very ubiquitous in a lot of fire code applications, buildings, obviously electric vehicles and products. We are also very active in transportation forums you certainly at domestic levels within North America, but specifically in international forums. We do participate in the UN Subcommittee of Experts on the Transport of Dangerous Goods meetings that meet every 6 months on a 2-year cycle for updates to the UN model regulations. There's a meeting coming up actually in about 2.5 weeks. And then other what I'll call the modes of transportation. This is just listing a few of them here, but we participate in the International Civil Aviation Organization Dangerous Goods Panel, as well as the International Maritime Organization. So quite a bit of activity, fairly differing, but also a lot of these activities do come together in some areas, particularly around safety. So I meant this slide to be extremely basic because, as designers, you're being asked to basically say, it's like, oh, this is simple. Design a battery that works in something. Seems pretty simple. I'm going to focus more on the battery side of this, but again, I will stretch into the devices to some extent. But okay, this seems really simple. But this is what you're being asked at a high level. But what the people that are asking you to do this, or the organization they're asking you to do this, is really what they want is something that, in the case of a battery, they want something that has infinite power. If it's rechargeable, it has infinite cycles. It has rapid charging. It doesn't take up any space. It doesn't weigh anything. It functions in essentially every type of environment that a consumer can imagine or a user. Oh, and importantly, it has no cost associated with it, and it's safe. Uh, okay, safety can mean a lot of things. It can mean personal safety. It can mean environmental safety, a lot of other things. So this is really so when you look at this, it's like, okay, you went from this really simple item to say, I'll just do this. But really what you end up with is you have a net or a filter of all these different wonderful ideas you may have. They're all going to get captured by something here, and they're going to slow you down. And this is not an exhaustive list of all the different filters, if you will, with the net. Um, but things like size and weight, the temperature during usage and storage and transportation. Oh, the voltage of the battery matters in a lot of cases, as does the power of the battery in watt hours or the capacity of it. I'm going to focus on the laws and regulations, as I said, but I wanted to capture other items on here like cost and movability too, just to say these are all at a high level things you're looking at. And I'm going to go back here a second. Remember this too. We're starting with simple. Okay, take a battery, put it in something. Okay, and then you're done. But the reality today is it went from that to this, and now you have all these things, but now we have to focus on circularity. And now all of a sudden there's nets on the back end too, and multiple nets on the back end. So you have to consider a lot of these things, not just on the front end of whether or not you can get the product to market, but now all of a sudden those materials or those products, regulators would like those materials to be used back into the industries, into other products, or in a lot of cases, directly back into batteries. And some laws in some areas specifically mandate that you have closed loop recycling or that you use spent battery materials in your products in order to be sold at certain levels. That is one of the number one things that I will always say to designers in this case is be thinking about that, because that material supply is not going to be robust in the beginning. It's working, the recycling industry is working on that, but there's going to be a huge competition for recycled battery materials coming in the near future. So be on the watch out for that. Think about that when you're designing your products. Um, so as I mentioned, I will cover, three categories here: chemical use, very briefly; collection and recycling a little bit more thoroughly; and of course, safety related to transportation, ingestion, and then just to a certain extent on just the use, reasonably foreseeable misuse and abuse, as is found in the various standards. None of these slides are meant to be completely exhaustive. I'm covering this certainly from a North American and to a lesser extent global perspective. And as I mentioned, some of these items we could go on for days about and create tomes of information. So this is just meant to say these are items that should be thought about. Obviously, if you're introducing a product in a particular area of the world, it should be highly considered that you that you look at what the local laws and regulations are. But this is at least a high level version of what you might be seeing right now. So chemical use, I mean, many of us go back and we know about mercury, cadmium, and lead in products. And in a lot of cases, that is out of products now, with some exceptions, like in cadmium with NiCad batteries, or obviously lead and lead acid batteries. Um, that is something that has been global. Um, PFAS is a hot topic right now, and I included it here in global, but it is something that is not completely global yet, but I believe will very shortly. I had a conversation this morning with the Korean Battery Association, and they told me, yeah, we're talking about PFAS, but not really digging into it too deep. And then you look at what's happening in the US where I am, and there are states and the federal government's looking at it. So PFAS is a very hot topic here in the US, and it's starting to get a lot of attention in Canada, in Europe, and some other areas as well. And for those of you that design batteries, you know many chemistries of batteries use PFAS in the batteries, and it is hard to substitute. Either that there is no substitute right now, or if there is one, it is not generally available or it is outrageously expensive. So it's something to really be thinking about. Some of the regulations around PFAS are saying that, okay, we'll give you a break for a little while, but maybe that might only be until 2030, 2033, and then you have to have it out. So that is something to definitely be considering now. Um, just at a high level then too, I mean, when you look at regulations, and this is not to say other areas of the world don't have, importance, but when you look at regulations, it seems like, out of Asia, a lot of what might be happening in China is going to be very influential. Obviously, China has, as an example, China Ross. Europe obviously is leading the way on a lot of, battery or just environmental legislation. They have been for more than a decade. Um, Big ones obviously are Reach and Ross in Europe. US too is really starting to hit the ground here on the collection and recycling. But from a chemical use, you have things like the Toxic Substances Control Act, as well as the Universal Waste Rule, that are important items to consider, among many, many other items. Like I mentioned, PFAS is one of them. So just as an idea, to always be thinking about chemical usage. And it's also important to understand that, think about the substitute that you're developing and what might be coming down the road. Because if a substitute can do something very similar to a current material that you're using, but it has a lot of the same properties, chances are 5, maybe 10, however many years down the road, that chemical or that substance may be in the crosshairs as well. So I always like to try to look at something to future proof it as best you can, so you don't have to repeat the work in the future, or in the long future, or even near future. At a high level here, when you look at collection and recycling around the world, countries or regions that are in red are where there is some form of active all battery collection and recycling. I'm taking some liberties here. There are definitely nuances in some of these areas. But in a general sense, they are collecting batteries. Some of my friends in Latin America will tell me it's like, well, it's not really happening completely in Argentina, for example. I know that, but they do have regulations. They just don't really enforce them right now. So there are some, like I said, some liberties taken here. Um, Areas in orange are a mixture like the US, which I'll show specifically here in a moment, or they are pre-active, meaning that they're doing something or that they have a mixture. So the US is, I would say, is more a mixture and pre-active, and then Japan, as you see over there, Japan has a mixture. They collect certain rechargeables, they collect button cells, but they do not collect primary batteries, for example. And then the yellow are ones where there's just a lot of discussion going on, and I would expect that those countries will have something in the very near future. But then again, all those countries that are in gray, they will be coming along at some point in the future. Um, Whether or not it's just by osmosis to some extent because the other countries all around them are doing it or not. In the US, this is very recently updated. The US has had an enormous amount of activity on battery extended producer responsibility in 2025. It was active even in 24 and a little bit before, but this is really the year of battery recycling in the United States. There were more than 20 states that were active in some ways. Um, I segment these, the colors represent things, and I'll quickly walk through those, but the US separates legislation by combining small and medium format batteries into one type of bill, and then large format, mainly EVs, but it could also theoretically encompass energy storage batteries as well. Um, the small and medium, as I mentioned, I lump those into one category called portable. think of small batteries as those that you can put in your pocket. Medium batteries are like e-bike batteries. An average person can still carry them around, not as much so in their pocket, but they can still carry them. And then obviously large format usually means you have a forklift to move that and the consumer doesn't interact with it. The way to look at this is yellow and red is portable, all battery types, essentially all battery types. And then the green is electric vehicle. They were specifically only electric vehicle bills this year. If it has hexing through it, it means that bill is dead for the year and will probably pop up again next year. Um, the states, so the yellow states are portable in medium format. The red states are also portable in medium format, but those are passed. Um, there are 8 entities as of yesterday when Connecticut's governor signed their bill that now have collection and recycling for all portable batteries that will begin as early as 2026 through 2028 now in those states. Um, there are some states, like if you look at California, for example, they're a little active in a lot of areas. So they are active in EV, portable, medium, et cetera. So they're active in a lot of areas. The green, as I mentioned, is electric vehicle. There is only one electric vehicle bill passed right now, and that is the little blue sliver in New Jersey. They will be mandatorily collecting EV batteries starting 2027, but I would expect a number of other states are probably going to be joining them very soon. So quite a bit of activity. Really, every one of these yellow states that didn't pass this year, we expect to see it next year, and some additional states we're hearing will also be active. In Canada, there are a couple of the northern provinces that just do it voluntarily. I mean, just based on the amount of population, it doesn't even really matter because they just get absorbed into the national program that exists in the other provinces. So essentially, Canada is a completely mandated country for collection and recycling of all battery types. So my organization, PRBA, we are very active in any legislative efforts, and actually PRBA has a model bill that we use. The model bill is focused on the portable types. So again, small and medium format. We are working with others on possible development of a EV model bill. There are like pieces, parts that are out there in different state or from different states this year. So that is something that's probably going to be developed by the end of the summer. But the model bill that I mentioned here, it will have a lot of very similar components to any type of battery bill. I'm not going to read through all of these. What I'm going to do on here is, so from a design perspective, I'm going to focus on 2 areas, the ones in red, and that is small batteries and where materials go in here. Certainly some of these other ones they're all important, but these are the ones from a battery designer point of view I wanted to focus on. The model language that we have talks about 3 or 4 items that have to be on the battery, and there are some limitations for size. So the first one being the producer. There is a requirement in the language that the producer be listed on the product. That way, it helps with identification of who's putting batteries on the market and also helps with the pursuit of free riders that might be on the market. There has to be a label to ensure proper collection and recycling. So some type of label that talks about what is the best thing to do with this. I'm going to skip to the last one and say, do not dispose of a household waste. Sub-bullet 2 and 4 essentially can be captured with something that looks like the European dustbin symbol. And that is what the industry is looking at now, because the laws that have been passed don't give guidance on what it can look like. They just say it has to do these things. The last one on here is sub-bullet 3, which is the chemistry, is something that is extremely important in a collection and recycling program, because there are 2 things, well, there's probably a lot of things, but 2 major things in a recycling program is that one battery chemistry can be a poison or an impurity to another chemistry, and they have to be processed separately, or they can outright be a safety concern. I know I've seen a number of, I've personally seen it and obviously hear about it, but lead acid batteries, so think of your square lead acid batteries, and there are now lithium ion equivalents to that are also 12 volts and look exactly the same. When you put a lithium ion 12-volt battery into a lead shredder, bad things can happen. So it's really a problem. So the chemistry of the battery is really important to be labeled on there so they can be sorted effectively. Um, the language, the model language is also recognizing that there are some batteries, like the example I picture here as a coin cell. Some of this stuff just can't fit on every battery. So the model bill currently has some limitations and some exemptions for what would need to actually be on the battery based on size. And we're looking at modifying this into the future. I'm actually working on this now to use the ingestion symbol that's found in many standards, not just in the battery industry, but in small parts in general, like the toy industry. That think of this as a, I know it's hard to read a little bit because it's two-dimensional, but think of a toilet paper tube that's cut diagonally. That's about what this looks like. And if that battery or anything else can fit in the hollow portion of that diagonal tube without breaking the plane of the diagonal, then that battery is considered, or battery or anything is considered small. And then potentially, if that is adopted, could be the gauge that is used to determine what is considered small and can get the exemptions on marking. Where materials go is the second one I wanted to focus on, at least from the model legislation. There is an enormous amount of pressure right now on pyrometallurgical recycling. If you think about it, there are essentially three very, if you bucket the types of recycling, you have mechanical recycling, which essentially is the shredding. I wouldn't necessarily say it's the recycling in its entirety, but you have mechanical, you have pyrometallurgical, or which is heat-based, and then you have hydrometallurgical, which is digestion or not heat-based digestion. It can be a little bit of both. What a lot of the recycling processes will do is they may use all three of those in their process. The focus on, or the potential prohibition on, pyrometallurgical recycling gets into the extremely high temperature, the smelting of metals, where you might be fuming off zinc, for example, and you might be at 700 C to be able to do that. Some of the discussions that have happened this year in some of the states, we're looking at saying, well, because pyrometallurgical recycling is energy intensive and uses a lot of and can emit a lot of greenhouse gases, we would like to exclude that from the possibility. The industry is not in favor of that. What we feel is that recycling should be agnostic. If you have a concern about greenhouse gases, put the greenhouse gas limitations in the legislation, not the technology to process the product or the batteries in this case, because theoretically somebody could invent a pyro process that captures greenhouse gases. So it doesn't limit the technologies. So, but that pressure still remains, and we continue to push back on that politely. Export is a big issue. With the batteries becoming more and more prevalent, the materials used in them are becoming more and more difficult to get or more expensive. And looking at this long term into the future, many countries are saying, well, we want to be able to keep those materials in our country. Completely support that. But in some cases, the processing, whether it be recycling or reprocessing in the metals industry, for example, it may not be available in every country right now. Maybe it will in the future, but right now, those materials may need to be exported. So that's something that really needs to be considered, is looking at, okay, there needs to be a network of this and until or unless other countries can say we have something completely within country. More so on the front end of recycling, movement of spent batteries in this case from remote locations. So think of places like Alaska, Hawaii, Guam, Puerto Rico. This is an enormous problem for them right now. The ocean-going vessels in a lot of cases are reluctant to take those batteries once they're consolidated on an island, for example. So Hawaii, I know, is looking at putting together a collection and recycling program, but then right now, even if you were to collect them, you can't get them off the island. So that presents a challenge. And then I know my counterpart from Recharge is presenting on this right now on black mass. Right now, in a lot of areas, black mass is considered as a waste. And that black mass is in a lot of cases, the feedstock for new battery materials in the future. Moving that as a waste is extremely complicated and can be extremely expensive. So there's some work that needs to be done on looking at this as like, well, can you move black mass as a product and not a waste? And that also gets into that export item that I mentioned. All right, so moving away from collection and recycling, I'm going to move into transportation, specifically as it relates to safety. Just a couple examples here. There are issues in transportation at pretty much every stage of a battery's life right now. The one in the upper left corner, for many of you that may have heard about this late last week, that is the Morning Midas that is still currently burning off the Aleutian Islands in Alaska, um, rumored to be an EV fire. We will see when we get more details, but there are incidents happening at battery factories. There are incidents happening at transportation or in transportation. It's happening at recycling. It's happening during use, like the Moss Landing fire right there in the middle at night. The one that's the night picture. It's happening when these are in the garbage, when they're picked up by the garbage trucks. Southwest Airlines just said if you have a power bank to charge your phone, you got to have it out and visible because they're having incidents where these are catching on fire. You can see the Air Busan incident from a couple months ago where that plane luckily was not in the air when that happened. Um, Countless issues that are happening related to safety, particularly in transportation. It's happening everywhere, not just transportation, but transportation is seeing the brunt of this to some extent. And we know when we're looking at batteries that some chemistries of batteries are treated as dangerous goods. In this case, I'll focus on lithium metal, sodium ion, and lithium ion batteries. And it doesn't matter if they are a battery by themselves with other batteries or packaged in and with devices. They have a UN number, which means they're considered, in this case, a class 9 dangerous good. Um, it's also important to point out these batteries have the same limitations and the same types of rules, whether they're unused coming on the forward part of the life cycle or they're being sent for recycling. Just because a lithium battery may be cycled several hundred times and may be discharged or partially discharged at the time doesn't mean it doesn't still have a lot of energy and potentially could generate enough heat to cause a fire. So the regulations apply in both directions. I'll talk some about the UN and what the UN is doing right now. The United Nations has dangerous goods regulations specifically for lithium or lithium ion, lithium metal, and sodium ion batteries, and there are testing requirements for that. And then there are also requirements for packaging and labeling, among other things, in the UN. So where the UN sits today, and many of you are probably painfully aware of this, the UN for lithium type batteries or sodium ion has what they call T-tests. On the on the middle to lower right there's a list of what those T-tests are. T1 through T8 are in the current regulations today. They have been for many years. Those are the tests that you have to pass in order to physically be allowed or legally ship lithium batteries that are either by themselves or in and with devices. The lithium battery regulations are somewhat complicated, and they were somewhat shoehorned into the regulations many years ago. And so what is happening now is there's an effort to consider I'll say it's simplifying. It's hard to believe that this chart is simplifying it, but it is actually simplifying it. But more importantly, it segments, and again, this is a proposal. This would segment the categories so that and what it does is it rewards safer designs. Because right now everything is painted with the same brush. And if you have a design that won't propagate, or even if it does catch on fire, it doesn't propagate beyond there, those batteries are going to be given maybe, if this is adopted, maybe a slight relaxation on what some of the rules are. But at the same time, those that are more problematic and don't pass the tests, or just show all kinds of concerns, they would be much more stringently regulated. So this is something, this proposal to add T.9 through T.13 on cell and battery propagation and battery and the gas flammability for the batteries if they do go into propagation. Those are proposals to add to the UN model regulations, and we shall see where this goes. We are at the beginning of our biennium, or every 2-year cycle within the UN. We have our first meeting of this biennium coming up in about 2.5 weeks. So we'll see where this goes. It's been in the works for many years, and it is still complicated, but there is a lot of discussion going on here. One of the important points too, when you look down here at these boxes with the different letter categories, those are, if you're looking at this from left to right, you would be more safer compared to less safe or more energetic or more problematic. So ones in the E and F category theoretically could have they would still have a class 9 label, but it might be a 9F. And then 9F would mean it has certain requirements for packaging versus, say, a 9A. Basically, this is what would, if it adopted, you would do what we currently do today, T1 through T8, followed by the new tests. And then just like we do today, you classify the battery as transported, then you apply the packaging instruction. One other point to point out here too is in T9 through T13, part of the proposal is to allow for state of charge testing. So if you know your battery is going to be shipped at 30% state of charge, you can test it at 30% state of charge. And theoretically, batteries will be less energetic when they have less energy in them. So it provides the ability to get some relaxation on the requirements for those that know they're going to be only shipped in a certain way. Now, if you charge it after you have it from point A to point B, and then you charge it to 100%, well, that becomes essentially a different battery type. And it would have to have testing to demonstrate that it does pass. Talked about briefly about ingestion. This is definitely something to be thinking about going forward. I mentioned that battery ingestion gauge, or the diagonal toilet paper tube. Be thinking about that when you're designing products, because this is being discussed globally. It is found today in some standards documents, but it will be laws in many areas, certainly more the populated areas of the world. It already is in the US, and it will be in Europe and Japan and other places if it isn't already in some cases. This thing is, these types of laws are completely agnostic to chemistry. They are just basically, if you have a battery that a child or anybody can ingest, that battery has to have certain things around it or marked on it, or has to be packaged in certain ways. So it covers not only the batteries as standalone, but also the devices containing them. The idea is, in particular, that children, small children in particular, cannot get a hold of these batteries, swallow them, and get them stuck in their esophagus, because the potential of that happening is, in some cases, it's deadly. So these rules look at child-resistant packaging, child-resistant battery compartment designs, marking on batteries, compartments, devices, etc., instructions, everything else, retail labeling, and also there's a requirement for, you have to have third-party certification to your packaging that it meets all the labeling requirements and is child resistant. There are only a handful of organizations in the world right now that do that child resistant testing. So it's creating a little bit of a bottleneck on testing. So it is definitely something, if you have a battery that has any chance of ever being accessible to a child, you need to be thinking about this. In the US, this is known as Reese's Law, REECE. And it is in the consumer product safety, the product safety parts of the Code of Federal Regulations. And then lastly on here, just general safety, use, misuse, and abuse is something always to consider. I know our IEC, ISO, ANSI type standards, as well as their counterparts in China, Europe, Japan, Latin America, all focus on this in their safety standards. You have to be thinking about this. They are definitely worth looking at. I know sometimes the standards can actually lag on what's happening in the market, just because standards can take years to develop. But they are definitely looking at what is trends in the market right now as far as safety, and it's certainly a good starting point to be thinking about. So I will go to my last slide here, and then I will welcome any questions. Just in general on trends, I mean, chemical regulations are not going away. They're only going to increase. Um, I highly encourage anybody that's looking at something, it's like really do your homework on materials that you want to use and see where they might be active. A lot of your trade associations anywhere in the world will be doing this. I do it on a daily basis. I mean, the first thing I do every morning is I grab my cup of coffee, which sadly is still half full, um, and read the Federal Register in the U.S. about what's coming. And a lot of times there's something in there about chemical usage or whatever. Um, Look at those, make sure that they're not already being looked at, or think about what you're using and how it may be impacted into the future. Um, Collection and recycling, I put the map back on here, obviously not going away. It's going to become more prevalent with higher collection rates. Um, it will be global at some point, or essentially de facto global. The whole closed loop recycling thing is a reality now and will only become more of a reality as we go forward. Um, Usually what we say within the industry is not that necessarily the materials have to be closed loop and battery to battery, but that they be available for closed loop. And that's because, the cobalt that's used in lithium ion batteries today may not be desirable in lithium ion batteries in the future. So it might need to go somewhere else. So we try to future proof the regulations. Um, Certainly the mandatory usage of recycled materials, as I mentioned, get a handle on that sooner than later because there will be competition for that material, guaranteed. Eco-modulation is just, how do you make a product that is better for the environment? Um, this is an area that is getting a lot of discussion, but is very challenging because who picks the winners and losers and under what categories? So if I make a battery that has recycled material in it, and my neighbor makes a battery using hydro-powered energy versus the recycled content one uses coal-fired energy, who's a greener product? Who's more environmentally beneficial? There are no rules or metrics around it, so it's very arbitrary at this point. So it's hard to measure, hard to track, but it is something that will continue to be pushed in regulations. Europe has it right now, but how you measure it, how you track it remains to be seen. Um, and then, of course, on safety and transportation, state of charge is a reality now. It's already a reality in air transportation. Based on some of the incidents, particularly that morning Midas EV fire, I know that the IMO has been looking at state of charge for maritime shipment. I believe this may accelerate it. We shall see. But regardless, state of charge is a discussion item or a requirement in some modes of transportation. And then, of course, the packaging that goes along with these products, whether it be for transportation or even ingestion, that is going to continue to be a difficult point. And think about that when you're designing batteries too. Packaging's expensive. If you have to use UN spec packaging that's certified and tested, that stuff all has a cost. And so if any relaxation you can get on your requirements around some forms of packaging is just going to make you more competitive. And then lastly, regardless of where you live or what currency you speak, none of these items are cheap. Every one of these, not only just the topic itself, but think about the time that it takes to look at all of these things. These are all the headwinds that you will face as you go forward. So they are all things to be thinking about when you're into a design, because going back to my original, slide that just showed the battery with a widget on there, it is far more complicated than just saying, pick a battery, put it in a widget. It's challenging, and that's what we all do. It's what we're employed for. So I will stop there. My contact information is listed on the first and last slide. I welcome any questions at any time. Certainly basic ones I'm more than happy to help with. Obviously, if you'd like to get into more detail, you need help on anything in particular, PRBA is here to help, as is the Wiley law firm. To let us know how we can help you. And with that, I will stop and take any questions you may have.